This is again a video on information coding. Basically, ideally this is actually meant to be a method for error detection and correction, but as it turns out, the activities of data compression and error detection and correction overlap, trying to write or come up with methods for both detecting and correcting any number of errors in them will more inevitably lead to the discovery of methods for compressing the same information, because it is a similar task. And conversely, trying to find methods for detecting as many errors as possible and correcting them also will lead to the discovery of data compression methods. So this is primarily, I was looking at it as a means of data error detection and correction, but it turns out that it is a good compression method as well. It can be a good compression method as well. Now, this idea behind this method is this. So we have an L' bit string here. This is bit 0 on the right, most trailing of bits, and this is the most leading of bit, which is L' minus 1 bit. This length of the message is fixed. So now what we can do is, okay, now consider it this length in binary base only. We code the total length. The information we keep is the length L', and then the number of ones in it, O. Okay. If we know the length L', we know the number of, and the number of ones, we know the number of zeros. Then the number of we also keep the number of values I or E, which is the number of ones in the even location. Okay. And from that we can also, knowing the length, we can infer the number of ones in the odd location. And then after that we keep the number of zeros in the even location. Okay. So number of even ones will be EO, number of even zeros will be EZ. So these four informations for the base 2 alone. Then what we do is we consider the same information in base 4, that is 2 bits at a time, and then we will keep a table of 3, right? So you will have 0 0, possibilities arise, that is 2 bits of 0 1, 1 0 and 1 1. If we know the sum of all of this, we should be able to infer the sum of this final one. So we can only need to keep 3, right? Right? And also once if we can infer this, if we know that this is an even one and this is an even one, so sum of these two must add up to this. This is an even 0 and this is also an even 0, so sum of these two must add up to this, and so on. right? So you should be able to know what these are. Like this only you can, then you take base 8 or 3 bits at a time. The same information only from left to right or right to left or whatever it is. So then you will have 8 possibilities like that, out of which you need to keep only 7. The 8th one can be inferred. Okay. So you will have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Right? Then you will take a table. Out of this you will keep only, right? So these two sums must add up to this one. These two sums must add up to this one. These two sums must add up to this one, and these two sums must add up to this one, and so on. Like this, you can have some consistency check as well as data compression here. Okay. Then you consider a table of size 4, which is 16, out of which you keep only 15 of those. Okay, 16th one can be inferred like this. So there will be 15 like this. Consistency check for that. Like that you can go up to say 8 or 9 for a very large file. That should be more than sufficient to be able to decode it, because the probability that all of these sums match will be very almost 0. Okay, this is intended. This can be used to also on a slightly smaller scale as well. If the number of, say if you take 4 or 5 as the depth to which base from binary base to base say 4, that is 2 power 4 or 16, or 2 power 5, which is say 32 or something like that. For a packet up to 4 or 5 should be more than sufficient, which is across a net, or even for an entire file also. This sort of coding will greatly compress the information. And also it can be used for consistency checking. That is, meaning the code is related to each other, so they can be consistently checked for consistency. Now this aside, now we look at how information can be actually, a simple scheme how information can actually be sent from across a network from a particular input. That is, the information is usually enclosed in a packet which is called similar to an envelope, which is headed by an address and stamped and sealed from the place of and delivered. And the kind of delivery we have also on the postal services, there is also registered post or recorded delivery, where the sender sends a package, and after delivering it he receives an acknowledgement. So we will assume that in the network also, if a particular source sends from one place to the destination, so source does not know whether the packet has been lost, or due to some error problem the information had to be discarded. So if it does not receive an acknowledgement within a certain period of time, it retransmits the packet. So for every packet it has to either, or if the number of packets that are received are small, in any communication, if a particular receiver does not receive a packet within a certain time, it sends that packet number back to this will require a less number of traffic, or like this will require more traffic. If this receiver does not receive, all the packets are sequenced. If a particular packet in a sequence does not arrive within a certain stipulated time, the receiver sends up that packet number which it has not received to the sender, and the sender retransmits only that packet, right? This will save the retransmission of this recorded delivery for each and every packet. Only for those packets which it has not received, the receiver sends the packet number. So all the information is sequenced for that particular file or whatever it is. Right? A typical packet consists in a network consists of the actual data here, right, and a header which contains some routing information and some error detection and correction information. Okay, I should draw it slightly bigger. Okay, let's say the header information consists of from where, that is the origin, from it must consist and particular to information, right? From to there might be several possible connections or whatever you call them, possibly some kind of a connection number or something like that, followed by a packet number, okay, followed by some code information, okay, for your error correction and the actual data. Okay, the ideal way to send this is like the method we used. So what we do is, firstly, this is to use a sort of a packet in packet, meaning first this data is coded in some such method like this, and that code is written here, which is called code 0, and the from and to and these informations, packet number and all of that, is filled up to form the packet. Okay, right? Then what happens is, now that this whole thing, okay, becomes the packet in itself, right? Now this is packet 0. Okay, now what happens is a packet 1 is constructed with from to this information being the same, but now the code and the data put together forms the data for which another code is constructed. So we can do this as follows. Right? Now again the same thing, only the same from part will be the same, most of the header part except for the code, right? To packet number, and then all of that connection number or whatever, and packet number, right? And then you will have here code of 1, and the data will consist of two parts consisting of, this is packet 1, right, and the data will consist of here the same from, to, connection number, packet number, followed by code 0, followed by the data. Okay, this constitutes the data 1 for the code 1. Now this packet 1 is transmitted across. Upon receiving, what it does is it decodes code 1. If it decodes code 1, it should get this packet. Then it will decode code 0. It should get this data. It will compare the decoded code 0 data with this data to check if the data is ideal. It will compare the decoded code from 2 can be compared, so can connection pack can be compared. Okay, so this way your delivery is secure. So data also gets checked, the destination, connection, all these information also gets checked. So you have twice you encode it, and then any kind of compression method itself might suffice for this kind of coding. This thing, the method I just outlined can be used, but or any other method can be used. Usually the size of the packet need not be too large at all. So this way, this is one possibility for error detection and correction across a network.